Let's do this problem right here. The question is asking, determine all force components exerted on pins A, B, C, D respectively, and they are also saying members AB, AD, and CD are all 1.2 meter long. So let's see how we can solve this. So first of all, in this kind of question, we have to separate this frame kind of questions. We have to separate all the components of this one and solve them separately. So in this case, I have to take AB first. So if I take AB first, let's see what happens. So this is A, this is B. So B has two forces, a vertical force, that's Bx, and a horizontal force By right here. And A also going to have Ax, Ay. Their directions are just an assumption. It doesn't matter which direction you choose. The answer will give you the details, because if you get a negative answer, that means the force is acting opposite direction to the whatever the direction we have taken. So in this case, we have one more thing, that distributed force right here. It's a triangle shape. So in this case, therefore, I have to take the area of the triangle. Area of the triangle is height times the length. So height is 200, and the length is 1.2 meter long. They said every component of this one is 1.2 meter. So we can multiply this one by 1.2 and divide it by 2. That's going to give us the distributed force. So if I divide this one, this is 100 times 1.2, so that will give us 120 Newton. And for a triangle, the force is going to be, distributed force is going to be acting from the 1/3 of the height. The distance is going to be 1/3 from the height. So in this case, we know this is 1.2 meter distance. Therefore, 1/3 of the 1.2 meters is going to be 0.4. So let's say this is 0.4. So the distributed force is going to be acting exactly right here. So it's going to be 120 Newton. So that's the only thing we have to know. And from this one, now I can calculate the moment, calculate the forces by taking moment around something. So I can take moment around B or moment around A. It doesn't matter. Both of them will give you the same answer. So let's take moment around A and see what happens. So if I take moment around A and take counterclockwise positive, this is equal to 0 in statics, and we have 120 Newton acting on this from 0.4 meter distance. So I can put that's counterclockwise. That's going to be positive. 120 times 0.4, and we also have Bx acting in the counterclockwise direction, so it's going to be positive too. So Bx, we know this total distance is 1.2 meter. That's given right here. So it's times 1.2 is equal to 0. And if I solve for this one, 1.2 Bx comes out to be 120 times 0.4. 120 times 0.4. Then this one will be Bx. So this is negative. If I bring to the other side, it's negative. Then 1 minus 120 times 0.4 divided by 1.2. That will give us, this is 3. Therefore, this is going to be minus 40 Newton. And we have done with this Vx part. Now let's see what we can do for the Ax, Ay and the By. Also, if I know Bx, I can calculate the Ax. If I take sigma f of x equal to 0 and take this direction positive, this will come plus Ax, and also Bx in the positive direction, so it's going to be plus Bx equal to 0. Therefore, I can substitute this one right here, so it's going to be Ax minus 40 equal to 0. Therefore, Ax is going to be equal to 40 Newton. So these are the two information we got from this equation, from this frame, and also I can form another equation, that's sigma f of y. If I take sigma f of y and take upper direction positive and solve for this one, let's see what we get. We have ay in the upper direction, so it's going to be positive, and by also in the upper direction, so it's going to be positive too, equal to 0. These are the only two vertical forces, therefore ay is equal to minus by. So we know this relation. So we have ax right here and bx right here. So let's see what we can find. Now we have did everything in the AB component. Let's move to the AD component. Let's see what happens. So if I take AD components right here, so what we have to do is whatever the force we are taking in this one, we have to do exactly opposite. We have to take the opposite direction on the other side. So if AX is acting on this direction, here is going to be acting in the opposite direction. So it's going to be AX right here, and AY is going to be acting downside. And also we have 400 Newton, 0.6 meter from this one. So this is 400 meter, 400 Newton, 0.6 meter from this one. And also we are going to have dx and dy. So let's assume this direction, dx, dy. So if I can solve one of them by taking moment around something, like for example, if I take moment around A, let's see what happens. So I separate this one right here. If I take moment around A and take counterclockwise positive and solve for this one, I will get 400. It's acting clockwise, so it's going to be negative. Negative 400 times 0.6. Then this is also negative because acting clockwise, so minus dy times the total distance is 1.2 meters, so minus dy times 1.2 equal to 0. Dx doesn't create any movement because it's along this line, so it doesn't create any movement. So we can solve for dy. We can find the dy from this one. So let's see what we get. So we know 1.2 dy is going to give us minus 400 times 0.6. Therefore dy is going to be equal to minus 400 times 0.6 divided by 1.2. So this will give us 2 right here. So minus 400 divided by 2 is going to be minus 200. So since we have the dy, I can calculate the ay if I take the summation of f of y. Summation of f of y is going to be equal to 0, and if I take upper direction positive and solve for this one, I'm going to have ay in the negative direction because acting downside, ay minus ay, and this is 400 also minus because acting downside, minus 400. Then dy is also negative because acting downside, minus dy is equal to 0. From this one I can find the ay, so ay is going to be equal to minus 400 minus dy we already know minus 200, so minus 200. So therefore it's going to be, this is plus 200 minus 400, ay is going to be minus 200. So if ay is minus 200, we have formed a relationship here. Ay is equal to minus by, therefore by is equal to plus 200. So we have found the three things. So let's see what we can calculate next. Okay, so let's move to the other component. So we have DC right here. So if I take that one, so let's separate this one. So if I take DC component, so this one, we are going to have dx and dy, but in this case this is going to be different because we are having this diagonal component. This diagonal component right here, that's going to change everything. So we shouldn't say this is dx. Let's say this is d prime x d prime x, and this is d prime y, and let's this is c. We are going to have cx right here, cy also cy right here. Then we also have 300 Newton acting 0.6 meter away from the D. So from this one I can calculate Cx because it creates a moment, right? So I can calculate Cx, and therefore I can calculate Cx and the D prime x. So let's do that one. So if I take moment around D and counterclockwise positive, and take this one 0, let's see what happens. So we are going to have 300 Newton acting clockwise, so it's going to be negative 300 times 0.6, and also we have Cx acting in the counterclockwise, so it's going to be positive Cx counterclockwise, and this 1.2 meter distance, because the total distance is this is given in the question, so we can multiply that 1.2, and these are the two things that's going to create the moment, so we can equalize this one to 0, and therefore 1.2 Cx is going to be equal to plus 300 times 0.6, therefore Cx is equal to 300 times 0.6 divided by 1.2, which will give us 150 Newton. So Cx is positive, and therefore the direction is same direction, and from this one we can calculate the d prime x by taking summation of f of x. So if I take summation of f of x, what's going to happen is this is equal to 0 in statics. If I take this direction positive, therefore d prime x is going to be negative. D prime x is negative, and Cx is in the positive direction, so plus Cx, and 300 in the negative direction, so it's going to be minus 300 equal to 0. So from this one I can calculate the d, so therefore d prime x is going to be Cx is 150 minus 300, therefore d prime x is minus 150 Newton. So we have calculated Cx and d prime x, and also we can form a relationship between d prime y and cy. So if I take summation of f of y, so if I take summation of f of y equal to 0 in statics, if I take upper direction positive and solve for this one, d prime y is going to be positive, it's acting upside, and cy is also positive because it's acting the upside. It's equal to 0 in statics, and therefore d prime y is equal to minus cy. So we have formed a relation between those things. So let's see how we can figure it out. So in this case we have to find the force that acting on this diagonal line too. So what we can do is, if I take the whole diagonal, I'm going to have too many unknown forces. So what I can do is I can take the pin D, but when I take the pin D, we have to be careful because all the forces I am taking in the d prime x, if acting this side, that's going to be opposite side here. So this force is going to be, so let's raise this one and put it in the bottom. Okay, default layout. Okay, so let's do this one. So I draw it maybe here to avoid confusion. So let's say this is D. So D is going to have force, this d prime x, if it's this direction, we are going to have d prime x in this direction. So this is d prime x, and d prime y is acting in the upper direction, so here is going to be down, d prime y, and also this d point is going to have these forces, so it's also the exactly opposite direction. So let's say this is dx, and therefore it's going to be right in this direction, and if I take dy up downside, so it's going to be acting upside. So from this one I can solve. Also we are going to have another force right here, the force created by this diagonal. So let's say that is Fd. So we can calculate that one by solving this one. Also we know this angle right here is going to be 45 degree, because we know this height is 1.2 meter and the width is 1.2 meter. So if we have equal distances for the opposite and adjacent, if you do tan inverse, that's going to give you 45 degrees. So we know that angle too, so we can calculate this one. And then from this one it's easy to calculate. Let's see, dy dx. So if I take, so we don't know d prime y, therefore we shouldn't take the summation of f of y, because we will have too many unknown. But if I take summation of f of x and solve this, and we know d prime x here and d prime dx also here. So summation of f of x is going to be d prime x positive, d prime x is positive, then dx is negative, then also we have ft, that's going to be ft cos 45, but it's going to be positive, plus ft cos 45 positive, which is equal to 0. And if you solve for fd, you will get, so d prime x we know 150 minus 150, dx we found out here, where is that, dx, did we calculate dx? So we found out ax is equal to 40 Newton, but we didn't calculate dx. We can calculate the dx by substituting this one to here. So dx is basically, so if I do the sigma f of x here equal to 0, and if I take this direction positive and solve for this one, dx is going to be positive and ax is going to be negative, minus ax equal to 0. Therefore this is going to be, dx is going to be equal to 40. So we calculate the dx right here. So if I substitute here, d prime x is minus 150 and dx is 40. So minus 150 plus 40 is going to be 110, minus 110, and if you bring to the other side, it's plus 110, and if you divide this one by cos 45, you will get ft is equal to 99 Newton. If fd is 99 Newton, this fb also going to be 99 Newton, because if this is fb, this is going to be fb. Both of them are equal forces. fd is equal to fb. Therefore, if it's ft is equal to 99 Newton, we know fb also, which is equal to fb. So we know these two forces right now, and from this information now we can substitute this d prime y. We can calculate the d prime y by taking the summation of f of y. So if you do the summation of f of y for this one, you will get d prime y as, so d prime y is 1/3, so 130, yeah. So d prime y comes out to be 130 Newton. So you have to do this, and I don't have enough space, so I give you the value. That's easy, because these three components are in the vertical. We know dy, we know fd, we can calculate the d prime y, that's 130 Newton. If d prime y is 130 Newton, cy is going to be actually d prime y is negative 130, therefore cy comes out to be 130 Newton. So that's how we find these answers, and that's all about it. I hope you guys like this video. See you next time.